2007 BC test Form B, question number 5. We're given the differential equation dy dx is 3x plus 2y plus 1, and we're asked for the second derivative of that in terms of x and y. So you're looking for the derivative of 3x plus 2y plus 1 with respect to x, and that is 3 plus 2 times dy dx using implicit differentiation, and we can substitute 3x plus 2y plus 1 for dy dx. And distributing, we get 3 plus 6x plus 4y plus 2. And finally, we get 6x plus 4y plus 5. And that's the answer for A. I'm going to skip ahead and do part C, see if I can finish C and D on this video. So we're looking to do Euler's method. We're starting at x equals 0. We know that f of 0 is negative 2, so I'm going to set up for Euler's method. Have my starting x and y values. I have my derivative with respect to x. I have my delta x. I have my delta y, which is dy dx times delta x. Then I have my new x, which is x plus delta x, and my new y, which is y plus delta y. Alright. And the starting point is x is 0, y is negative 2. Plugging in 0 and negative 2 for x and y into 3x plus 2y plus 1, we end up with negative 4 plus 1, or negative 3 is the derivative. We're given that delta x is 1/2. We multiply the 2 and get negative 3/2. And so we end up with our next point is x equals 1/2 and y equals negative 7/2. Now we're going to plug these values in. When x is 1/2, 3x is 3/2. And 2 times negative 7/2 is negative 7, or negative 14/2. That gives negative 11/2. Multiplying that by 1/2, or we have a delta x of 1/2 still. So I'm going to back up just a second. So I didn't add that 1 onto the end of the dy dx. It was 3 times x, which is 3/2, and then 2 times y, which is 2 times negative 7/2, which is negative 14/2, and then plus 1. So that gives a final value of negative 9/2. And we have a delta x of 1/2, so that gives me a delta y of negative 9/2. So now I'm going to add my x and my delta x. That brings me up to 1. Sorry, once again another mistake. The delta y should now be negative 9/2 times 1/2, which is negative 9/4. Okay, so now we're going to we started at negative 7/2, which is negative 14/4, and we're going to subtract 9/4, so we end up with negative 23/4. And so f of 1 is approximately negative 23/4. Okay, so part D, we have another Euler's method here. We have another function that's going to be a solution to the differential equation. And you have the initial condition that g of 0 is equal to k. So that means x is 0 and y is k. And starting at x equals 0 with a step size of 1, we get an approximation of g of 1 is equal to 0. So with a step size of 1 means my delta x is going to be 1, and my approximation of g of 1, which means my ultimate x plus delta x, will be 1, and that value is equal to 0. Now when I plug x equals 0 and y equals k into the original differential equation, which was 3x plus 2y plus 1, when x is 0 and y is k, I'm going to get 2k plus 1. And multiplying that by the delta x is still 2k plus 1. Now my y plus delta y is going to be k plus 2k plus 1 has to equal 0, which means that 3k plus 1 is 0, so k is negative 1/3. And that's all we had to do for that one. It was just one pass through with that, and k is equal to negative 1/3. We'll do the next part in the next video, part B.